Hi students, in the previous video we learned how to find out angle between a line and plane is given. If the plane is in the vector form and line equations are given, how to find out the angle between them. That is what we learned in the previous video. Now in this video we are going to again learn the same concept, that is angle between a line and a plane, but here the difference is plane equation will be in the normal form. So that is what we are going to learn now. If the plane equation is in the normal form and the line equations is given, then how to find out the angle between these two. That is what we are learning here. If the direction cosines of the line and normal to the plane are L1 M1 N1 and L2 M2 N2 respectively, then we know that line equation can be written as r vector is equal to a vector plus lambda times of b vector, where a vector is the position vector of a point through which this line passes. For example, this line passes through x1 y1 z1, hence its position vector is x1 I cap plus y1 j cap plus z1 k cap plus lambda times of b vector. B vector is the direction ratio of the vector which is parallel to the required line, hence the direction here, direction ratio, otherwise direction cosine. Here we are considering direction cosine, so plus lambda times of L1 I cap plus M1 j cap plus N1 k cap, and here we are given normal form of the plane, hence r vector dot L1 I cap plus M1 j cap plus N1 k cap equal to d naught, where d naught is the distance between the origin and the plane, and then the angle between the required angle between the given line and the plane is given by, you know that it is complementary angle, hence cos pi by 2 minus theta is equal to L1 L2 plus M1 M2 plus N1 N2. We know that cos pi by 2 can be pi by 2 minus theta can be written as sin theta, hence the equation of the normal equation of the plane is given and the direction cosine of the line is given, means the angle between them is calculated using this formula. Now what we are going to do is we are going to solve problems based on the concepts we learnt today. The first question is find the angle between the planes. If you observe it, here the two plane equations, vector form of the plane equations are given. When we need to find out angle between the planes, we need to find out their respective normals and then we need to find out the angle between the normals. We know that the vector form of the plane is r vector dot n vector is equal to d. When we compare it, we come to know that normal vector of this plane is I cap plus j cap plus 2k cap, and normal vector of the second plane is 2 I cap minus j cap plus k cap. So now we can apply it in the formula that cos theta is equal to n1 vector dot n2 vector divided by modulus of n1 vector into modulus of n2 vector. So we know that dot product of two vectors has to be calculated, means coefficient of I cap should be multiplied. Here coefficient of I cap is 1, here 2, so 1 into 2, and then plus coefficient of j into coefficient of j, and then plus coefficient of k into coefficient of k divided by modulus of this vector. You know how to calculate it. So finally the answer comes as cos theta is equal to 3 by 6. When we simplify it, it is 1 by 2. Theta is equal to cos inverse of 1 by 2. We already learned that here the angle that we calculate is the acute angle, hence theta should be equal to pi by 3. I hope you understand this problem. Now we move on to next question. The next question is find the angle between the planes of these two planes. Now if you compare the difference between these two questions is, in this question the plane equation is given in the form of normal, but here plane equation is given in the form of Cartesian. In the Cartesian form, plane equation is given means coefficient of x, coefficient of y, coefficient of z is giving the normal of this, direction ratio of the normal of the particular vector. So the angle between the planes a1x plus b1y plus c1z plus d, if you observe this equation of the plane, Cartesian equation of the plane, a1 b1 c1, we know that they are direction ratios, they are just coefficient of x, coefficient of y, coefficient of z. Similarly, for the second plane, Cartesian equation given means the coefficient of x, coefficient of y, coefficient of z gives us direction ratio of the normal of this particular plane. When you compare it, you can find out the direction ratio of the normal of this plane equation as well as direction ratio of the normal of the second plane equation. We are just applying it in the formula and we are simplifying it. Finally, we are getting the answer as cos theta is equal to 3 by 6. You know that it can be cancelled out and it can be written as 1 by 2. Hence, here cot theta we calculate is acute angle. Hence, it is 30 degree. 30 degree can be written as pi by 6. I hope you can understand this problem. Now we move on to next question. The next question is find the angle between the line r vector is equal to I cap plus j cap minus 3k cap plus lambda times of 2i plus 2j plus 2k cap and the plane r vector dot 6i cap minus 3j cap plus 2k cap is equal to 5. Now we need to calculate the angle between the line and plane. So the formula is angle between the line and plane means sin theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by modulus of each normal vector. Here the line equation, in the line equation we need to find out the normal vector. We know that this vector is the position vector, that means 1 comma 1 comma minus 3. Through that coordinate this line passes through, hence it is the fixed point position vector. This one gives us the direction ratio of this particular line. So we know that line can be represented r vector is equal to a vector plus lambda times of b vector. A vector is the fixed point vector through which this line passes through and b vector is the direction ratio vector. So a I cap b j cap plus c cap k cap, and we know that plane equation can be written as r vector dot n vector is equal to d, where n vector lies here. Here this is the n vector. So we got the normal dr of normal of the line as well as plane, and it can be substituted in the formula. If you compare it, the direction ratio of the normal of this line is 2 comma 2 comma 1, right? And then for the plane 6 comma minus 3 comma 2, and then we can do this calculation. When we do the simplification, we are getting the answer. So finally theta is equal to sin inverse of 8 divided by 21. I hope you can understand this problem. It is a very easy problem. Now we move on to next question. The next question is find the angle between the line x minus 2 by 3 is equal to y minus 1 divided by minus 1, which is equal to z minus 3 divided by 2, and the plane 3x plus 4y plus z plus 5 equal to 0. Now if you observe this question, we are calculating the angle between the line and the plane. So in order to do it, we need the direction ratio of the line as well as direction ratio of the normal of these planes. We already learnt that direction ratio of the normal or in the plane is just coefficient of x, coefficient of y, coefficient of z. And if you look at this line equation, it is in the form of Cartesian form. Here the line passes through 2, minus 1 and 3, because the Cartesian form of the equation, when it passes through a given point, fixed point, and direction ratios are given means the formula is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Our aim is to find out the value of direction ratio of the line as well as direction ratio of the normal to this plane. Direction ratio of this line, we must make sure that the given equation is in this exact form. But here if you observe it, y plus 1 is there, so it has to be written as y minus of minus 1. And then z coefficient should be 1, x coefficient should be 1, because here x coefficient is 1, y coefficient is 1, z coefficient is 1. So all of them satisfies. Hence this 3 minus 1 comma 2 is the direction ratio of this line, and direction ratio of the plane, as we know, coefficient of x comma y comma z, by which we can apply this, because sin theta is equal to a1 a2. This can be considered as a1, and this direction ratio of the normal of the plane can be considered as A2, B2, C2. This can be considered as A1, B1, C1. Hence the formula is A1, A2 plus B1, B2 plus C1, C2 divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. When we simplify this, we are getting the answer. I hope you can understand these problems clearly. In the next video, we will discuss some more problems related to this concept. Thank you students. Thanks for your cooperation.